Spheres.
The spheres? So the spheres. So who remembers what is the equation for the volume of a sphere?
Pi r squared.
And that's the volume of a sphere?
Or no, that's volume of a circle, sorry.
Okay, that's the volume of a sphere.
It's 4/3. Pi r cubed.
All that.
It's all the same.
Actually, you can go that route. So, where does this come from? Does everyone remember?
The orange thing.
Orange, yeah. What did you do with the orange?
You sliced it in half, and then you stamped it on your paper, and then you peeled off the peel and put it on it.
Okay.
And somehow that equaled 4/3.
Somehow?
Yeah.
I was thinking that this one was the one where we had the Play-Doh and we stuck it in cylinder, wasn't it?
It's there. You actually did those the same day.
Are they the same? Okay. Or
It's the same day.
Okay, so
It's
not
the same day.
Okay, sorry.
No, you're fine. Fine. No, continue with your thought.
Because that would make sense to me because it was 2/3 of the cylinder, and the cylinder is 1/3 pi r squared, I think it was. And so then when you go 2/3 plus 1/3 pi r squared, then it equals that. So that's why I thought it was the Play-Doh and then the cylinders.
What's everyone remember the surface area equation for a sphere?
And then I think that one was the orange.
Yeah, something similar, yeah. That's exactly what the orange is. The orange was the surface area. This Play-Doh was the volume. And so that's essentially, Brother Piper built the idea, he started with a cone, and then he poured the water in, and it was always like a third, it was always by a third. And when you cut the sphere, I could try to draw a sphere. And you cut it up, like it's, the 4/3 is the ratio if you put this in it in the cylinder. Just like when you did the cones and the Play-Doh. And that's where it comes from. So, we will start with A, 11A. What is the volume of a sphere with a radius of 3 meters? So, what is the answer someone got? 36 pi. Everyone agree? For A. And B, what did B ask you to do?
5 times bigger.
5 times bigger. So how are we going to change this equation? Because for A, we had the equation A equals, for A we had 4/3 times pi 3 cubed equals 36 pi. What's the equation going to be for B?
4/3 pi 3 times 5 cubed. Because it's 5 times the size, right?
Inside or outside?
Inside.
Okay. That's the answer.
Let's see.
What was your answer?
4,500 is fine.
Does everyone agree?
Yep.
Yes.
And who would like to come up here and do C?
C with half the size. No.
What is the reference size?
7 times.
No one wants to come up here and do C?
Let me pull it up. Tell me what the radius is supposed to be. It goes by. Or which one? 10C.
Look for spheres, bottom of the page.
Volume 6 times bigger. That's just.
7 times.
7.
Is it? Oh, sorry, I was looking at 10. My bad. So it's 7 times bigger.
2, 3, 4, 8.
That's happy. Like, just this part or the whole part?
The whole thing.
You say 1, 2, 3, 4, 8?
Pi.
Happy. Yay!
So this is our original. How many times bigger is B than A?
125.
125 times.
How much times is C bigger than A? Sorry.
343.
20 cubes
Or
times.
7 cubes times, sorry.
So that's fun, dude. So you said 7 cubed times larger, and this was how many times larger?
5 cubes.
5 cubed. So there's a pattern there. What's the pattern?
And
N cubed, and N being
the increase in size, or the multiples
The-
in size, increase or decrease.
well, it's the increase, not the multiples of the increase inside, but well, you made it 7 times bigger, so it's 7n. That's n equals 7, and this is 5n. Well, n equals 5. So that's where it gets us to the n cubed. N cubed times bigger. And it's because when you think of it, if you take a two-dimensional object, and we'll just start with the perimeter, and that's why I started with the perimeter, and this is a 2 by 2. Well, 2 by 3. If you double each side, you know, this became 4 and this became 6. You're increasing by that amount, and since it's a two-dimensional object, it's n squared, right, for the area. And since volume is a 3-dimensional object, you're increasing it, you're multiplying it by 7, and since it's 3 times, you're doing each dimension by 7, it's a 7 times 7 times 7, which equals 7 cubed, or n cubed. Does that help, or did that make it even worse?
No,
Okay, cool, cool. Any other questions? Let's go.
This is PowerPoint on the island.
This is Long Island. And the stuff we covered today, on Tuesday of next week, we will be having a field trip. So you'll be coming in here, having the devotional spiritual thought, and we'll get some supplies, and then we'll split up into groups, and you go off and you'll have a field trip. And we'll be using the techniques in here, in this PowerPoint, this PowerPoint, and the ideas of last Tuesday to find the answers. What you're going to do is you're going to go out and you're going to find heights of buildings and height of a pole using similar indirect measurement and similar triangles. So good notes, and I think currently it's supposed to be in the 80s next Tuesday. But this is Idaho, stuff happens. I'm prepared.
So we're gonna measure things per class period.
Yeah, pretty much. You get to go outside and be active.
Good.
I think that's better than just sitting in here. Don't you think?
Yeah, I like that.
It's a nice reflective. So, indirect measurement. Who would like to read the first paragraph?
Frequently, we encounter situations where measuring a distance, height, or length is either too dangerous or impossible. There are a number of ways that indirect measurements can be taken using mathematics or technology.
Who can think of a dangerous situation? Taking a height of an object real quick.
just like what we talked about last time, measuring the Statue of Liberty, that would be so hard and dangerous.
I agree. I don't want to do it. Could anybody think of technology besides a laser pointer that you could use for this? You know, any of your experiences with yourself, or maybe you have a brother that's in Boy Scouts, or you were in Boy Scouts? I'll teach you that later on then. For example, you can buy a laser distance measuring tool for about $100, and all you have to do to find the distance of it to an object is to point the laser at the object and pull the trigger. The gadget will give you the distance to the object with a high degree of accuracy using some physics and mathematical computations programmed into the unit. Trigonometry is another great tool to find indirect measurements. Knowing an angle and only one measure of a right angle triangle allows you to find the length of the other two sides of the triangle. Who here has taken trigonometry? Cool. Then you like the second. However, since we do not have a laser measuring tool and trigonometry is not the focus of this class, we will use the concept of similar triangles to determine indirect measurements. Would you like to read this paragraph?
We will look at 4 different ways to use similar triangles to take indirect measurements. In order to use proportions in our calculations, we need to be assured that the triangles are similar triangles and therefore have sides that are in the same ratio. To determine if the triangles are similar, we can call on one of the shortcuts that we learned in a previous class to prove that they are similar.
So, a quick review. What are some of the shortcuts?
Angle, angle, side, angle.
Cool. Next paragraph, we'll let the last half of the slide.
Here are the methods that we will be learning. Make sure that you understand each method and can justify the use of similar triangles before setting up your proportional computation. Mirror method, shadow method, triangle within a triangle, and horizontal distant method.
The mirror method relies on the physics principle that when light strikes a highly reflective flat object, the angle of incidence, that's the incident angle right there, the angle that incoming light ray makes with a plane of a highly reflective object is equal to the angle of reflection. The angle that the outgoing reflective ray forms with the plane of the mirror. Does everyone remember what a ray is? What's a ray?
Point one. It's like they're coming from the other direction.
So what are the two rays here then?
Got a ray going down.
There's letters there for you to help distinguish.
Oh, sorry, I'm far enough away. I can't see where they.
Dude, I understand. I'm blind as it is as well. We have ray EX and ray XF. The principle tells us that the angle EXP is congruent to the angle FXB. We also know that the flagpole and the person are standing perpendicular to the ground. This gives us a second pair of corresponding angles that are congruent. Angle XPX is congruent to angle FBX by the angle similar shortcut. The two triangles are now known to be similar. Therefore, by the definition of similar triangles, the three pairs of corresponding sides are the same ratio. Everyone agree? Therefore, ray EP over FB equals the ratio PX over BX equals the ratio EX over FX. We really don't need the last ratio, and we can measure directly the values for EP, PX, and XB. This will all allow us to solve for FB. Let's read this.
In this diagram, the person and the lamppost are both perpendicular to the ground, forming a 90-degree angle in each triangle. So we have one pair of angles congruent. The shadow method takes into account the fact that the sun is so far away that all of its rays that hit the earth are parallel to each other. Therefore, when two parallel lines, the sun's rays, are cut by a transversal, the ground, the corresponding angles are congruent. This gives us the second pair of congruent angles for each triangle. By the AA similarity shortcut, the triangles have to be similar. If they are similar, we know their sides are in the same ratio.
Does everyone agree that this has to be true? So I know it states it in there, but is there any way that you can explain why besides that? You don't have to answer, I'm just trying to get your mind to think. Because remember that you'll have students that you'll be trying to teach them something, this principle or something similar, And you know it as this, because we defined it as this, and you've done the homework and you've done projects. But sometimes, even though to us it's clear as day, you will have students that just won't understand. And the reason is because they think much differently than you. And the moment that you can actually change the way you think to the way they think, or at least model that in your mind and say that, then you're going to be such a great teacher. I'm sure all of you will be great as it is, but you can always become greater. So think of that. Therefore, 5.25 over x equals 6 over 18. We can easily solve this equation by cross multiplying. Okay, read this one.
The triangle within a triangle method also has a pair of angles that come from the person and the tree being perpendicular to the ground. This gives one congruent angle for each triangle, 90 degrees each. The other angle comes from the fact that the angle on the lower left belongs to both of the triangles. Therefore, by the angle-angle similarity shortcut, the small triangle within the larger one and the larger triangle are similar. This means that their sides are in the same ratio.
So basically what this principle is you have a person standing here, and then you'd be looking at the top. And the moment the crown of their head is the same height of the tree, as you tell the person standing here, stop. So who, from the lessons we've had in the previous slides, what equation would you find here? Any guesses?
Pythagorean theorem.
Well, you're going to be using the Pythagorean theorem. You can use the Pythagorean theorem, but there's a couple reasons why. But before we find that is you have to do the ratio. We're doing ratios too, remember. And if you take the last slide, you know we had this. We found that by taking 6 over 18, and then x was corresponding to the height, and 525 is that ratio. Even though I know you just saw it by me clicking out, what is the? Does anyone take a guess of what equation you have there?
I have 1.82 over the height of the tree.
Put it on the board, or on that board, doesn't matter. You have better chalk over there.
So we have 1.82 over the height of the tree, and then we have 6.30. 6.10, sorry. Over, and that's 12.20. 20 plus 6.10. So we have to add the distance from the person because they're inside the triangle.
That was the question.
You're mostly height of small, overhead big, bottom of small, top of big. Good job. Horizontal distance method. Any volunteers?
You may be asked to find a horizontal distance, like the distance across a narrow canyon or a river, rather than a height. If so, here is one way to approach it. Locate a tree or a rock on the far side of the river, which is point A, and drop a pebble or other marker at point B, which is straight across from point A. The segment AB should be perpendicular to the river. Then, walking along the river, drop another marker at point C. It can be any distance you want. Continue walking along the river and drop another marker at point D. Any distance works. Now, walk away from the river in perpendicular direction until you arrive at the point where point C lines up with point A. Drop a marker here at point E. Are the two triangles that you created similar? Since AB is perpendicular to BD and BD is perpendicular to DE, we have a pair of angles that are congruent. Since the points ACE are collinear, angle ACB and angle ECD are vertical angles and are therefore congruent. By the angle-angle similarity shortcut, triangles are similar.
A lot of words.
I know, I just laughed.
Who can sum that up? Anybody?
People wanted to stand up like a demonstrator.
Fine with that.
It's not super big, but
If you can get the volunteers.
anybody want to be a pebble or a tree?
Or a statue. That's a little bit more flattering than a pebble or a tree.
I'm just going on the exam.
I can sum it up. I can try. So that a long time ago when we were doing our first unit, when you extended the shapes to get the angles, that's exactly what's happening here. That line, where you started with B going towards C and D, is just extended.
Press that
That's
laser
okay.
pointer.
You could do it. For me.
Okay.
So
Oh,
from
you're
B-
pointing to it. You're describing it.
Wait, is there one in the middle?
The top.
Okay, so from B this way, from B to C, it's just extended to D, and from A to C, it's just extended to E. So we know that they have to be similar because it's just the extensions of them. That makes sense to me. I don't know if that's always true.
No, that does make sense.
Jeez, good job, thank you. Cool, does anyone see anything else that from your previous first unit actually is?
The vertical angles will always be the same, so.
Top.
So like, this angle here will always match this angle here, and where we have right angles here, we know that there's two angles in each of the triangles that are the same. So that means, the angle that helps here and the angle here are always the same also. So that's the way I looked at it.
I love that. No, exactly correct. Wonderful. And you actually hit the points that I wanted to be hit on, so it's even better. So yeah, that's exactly what it is. So let's look at it. Therefore, A over E equals C over D equals B over F. Again, we don't need the last ratio, and we can directly measure C, D, and E. We can then solve for A, the distance across the river. So next Tuesday, apparently there will be a river now here in Rexburg that will have alligators in it. That'll be somehow good here. And I'm fine with that because I'm from Louisiana. Alligators are fine, they taste good. Actually, they're fantastic.
What do they taste like?
Chicken, something like that. It's juicier, and you can't eat the whole. Like, there's a lot of things you can do with it. Anyway, so does everyone see how that ratio of A over E equals C over D? Because it's exactly like the homework question. It's very similar. I should say, not exactly like. It's similar to problem 3b, even though it's not perpendicular, it's still at ratio, it's same in the fine ratio. And that's it. Any questions? Any questions? No? Then we're done.